Hello, hello, hello. Hello. My voice is audible. Hello. Okay, okay, okay. So write down in proportional controller, the output of controller is simply proportional to the error E of t. Full stop. The relationship between error, the relationship between error E of t and controller output P is defined or determined by constant called as proportional gain constant, called as proportional gain constant, and is denoted as capital K and small p, Kp. Full stop and next line. The output of controller is a linear function. The output of controller is a linear function of error E of t. Thus, each value of error has a unique value of controlled output. Has a unique value of controlled output. Full stop. The range of the error which convert 0% to 100% controller output. It's called proportional bond. Full stop. Write down the mathematical expression of proportional control. P of t is equal to constant of proportional into error plus output, control output. P of, P of t is equal to Kp into E of t plus P0, where Kp is equal to proportional gain constant and P0 is equal to controller output with zero error. PYA roll number 49. Sachin, who is it? PYA roll number 49. Sachin Wagmare. Then write down direct and reverse action is possible direct and reverse action is possible in the proportional control mode. The error may be positive or negative because error is R minus B and B can be less than and B can be less than or greater than R. Next heading, integral controller, capital I. Give the heading, integral controller, capital I. Integral controller, capital I. Okay. So in the title, integral controller, it is mean the signal error is the derivative of the controller output, PT. Okay. So here see the description. The value of controller output, P of T, is changed at a rate which is proportional to the actuating error signal, E of T. Means actuator error signal, E of T, is directly proportional to the rate of change of controller output, P of T. Okay. So mathematically, dpt divided by dt is equal to ki E of t, where ki is a constant of integral, kp is the constant of proportional. So ki is the constant relating to the error and rate. The ki is also called as integral constant. Okay, and the expression is obtained to the control output at any time t. Therefore, capital P is equal to Ki integration of E of t dt plus P of O, where P of O is the controller output when integral action starts, that is at t is equal to 0. Means integral action start means you give to feedback or input or input source or input channel to the controller. So at that time t of at t is equal to 0 means starting stage of this controller. Okay. So these are the two graphs. So before taking graph, you have to write down the integral control I. The value of controller output PT is changed at a rate which is proportional to the actuating error signal E of t, and in mathematical expression dpt divided by dt is equal to ki E of t, where ki is a constant relating to the error and rate, where ki is a constant relating to error and rate, and the Constant Ki is also called as integral constant, and integrating the above equation, integrating the above equation, actual controller output at any time t is capital P is equal to Ki integration of E of t dt plus PO, where PO is equal to controller output when integral action starts. That is at t is equal to 0. Draw these two graphs. First one is related to the error and second one is related to the controller output. Draw it. Okay. So write down the output signal from the controller at any instant is the area under the actuating error signal, under the actuating error signal curve up to that instant. So in first graph error E of t at the higher level, their graphs is actuating error signal curve is directly downward to the zero line. Okay, and then controller output starting to the E of t is equal to zero. Then output at higher point, this graph will be the straight line. Okay, then if the value of error is doubled, value of error is doubled, the value of pt varies twice as fast, that is rate of the controller output change also doubles, change also doubles. Draw this graph. Draw this graph. See the graph. This is the output. Vertical display the output of this graph, and horizontal gives the error. So, so Ki means constant of integral is equal to Ki, and K2 is equal to constant of integral. So K2 is less than to the K1. Here minus and here plus. So midpoint of this 0, here 0 0, and K1 is in higher point and K2 is lower point. That's why K2 is lower to the K1. Okay. See the errors. This is the displaying the errors and change of rate of output P of T. So error will be the increases, output will be the decreases, and error will be the increases and output will be the decreases, and error is decreases, output will be the increases. Means this error dependent upon the output P of T. This is vice versa. So done. The scale factor or constant, the scale factor or constant Ki expresses the scaling between error and controlled output. Thus a large value of Ki means that small error produces a large rate of change of produces a large rate of change of PT and vice versa. Then give the heading derivative controller, capital D. Derivative controller, capital D. So the output of controller is totally depend on the time, rate of change of actual error. So hence it is called as rate action mode or anticipatory action mode. Rate action mode or anticipatory action mode, and his mathematical expression are P of t is equal to Kd means derivative gain constant d by dt E of t plus P of O. So E of t is the error, P of O is the control output. Okay? And it indicates by how much percentage the control output must change for every percentage per second rate of error. Okay, understood? So write down in derivative controller capital D, the output of the controller depends on the time, rate of change of actual errors. Hence, it is called as rate action mode or anticipatory action mode. Mathematically, P of t is equal to Kd into d by dt E of t plus P of O, where Kd is equal to derivative gain constant. It indicates by how much percentage the controller output must change for every percentage per second rate of the error. For every percentage per second rate of the error. So draw these two graphs related to the error versus time, and second graph is the control output versus time. Draw this graph. Draw these two graphs. First one is the error versus time, and second one is a control output percentage versus time. So generally, constant of derivative is expressed in minutes, okay, and constant of integral is expressed in seconds. So generally K of D, constant of derivative, is expressed in minutes. The important feature of this type of constant control mode is that for given rate of change of error signal, there is unique value of control output. Means rate of change of control mode is directly proportional to the rate of change of error signal. Also, the advantage of that is respond to the rate of change of error and can provide the significant correlation before the magnitude of the error becomes too large becomes too large, okay, and These two diagrams display the derivative mode change, the controller output for the various rate of change of errors. Okay. Then next point is that proportional plus integral type controller. In bracket, PI controller. Give the heading proportional plus integral controller in bracket P plus I controller. So proportional controller output is the Kp into E of t, means constant of proportional into error plus Ki म्हणजे constant of integration of E of t into dt. This is the output of combination of proportional plus integral type controller. Okay. So write down in proportional plus integral type controller, PI controller, a controller in the forward path which changes the controller output corresponding to the proportional plus integral of error signal is called is called PI controller. Write down mathematically expression. Output of controller is equal to Kp, constant of proportional into E of t, means error, plus Ki, constant of integration of E of t dt. And the important advantages is that one of the corresponds of P, one of the corresponds of P mode is available, proportional mode is available, comma I mode, integral mode, and the integral part of such composite control provides composite controls means proportional plus integral control provides a reset of the zero error output, reset of the zero errors output after a load change occurrence, after a load change occurrence. Draw these two graphs. One is the error versus time and second is the control output versus time. So this is integral action time. Draw these two graphs. So today stop here, place your roll number and leave the meeting.